In which situations are Newton's laws of motion not applicable? Well, Newton's laws are not applicable at very high speeds, generally more than 10% the speed of light. Now, light is very, very fast. In fact, it's the speed limit on everything in the universe. Nothing travels faster than light, as far as we know. It's about 186,000 miles per second, or 3 times 10 to the 8th meters per second. So very, very fast, but when we begin to approach that speed, Newton's laws don't really apply. So we have to resort to other things. Relativity theory describes motion at high speeds. Newton's laws of motion are not applicable on molecular and atomic scales, which are about a nanometer. A nanometer is 10 to the minus ninth meters. So if you take a meter and divide it into billionths, okay, a millionth of a millimeter, if you've ever looked at a meter stick, those tiniest divisions, millimeters, if you divide that by a million, that's a nanometer. So very, very small scales. Quantum mechanics describes the behavior of matter at atomic scales. Very, very different behavior physically from the way things behave on our scale of things. How can Newton's laws of motion be applied to practical problems involving forces in motion? Newton's laws apply to many classes of problems, including inclined planes, circular motion, pulleys, and falling objects, all kinds of stuff. People travel to the moon with no more consideration than Newton's 3 laws of motion, right? We didn't have to use relativity or quantum mechanics. By the way, a bunch of people with slide rules too, so not much computing was involved in, there was some, but not much was involved in getting people to the moon. If the forces on an object are known, Newton's laws can determine its motion and its changes in motion. If the motion of an object is known, Newton's laws can determine the forces it is subject to, as it can be seen from the equation for Newton's second law. Again, we have a little microscopic version of the second law there, courtesy of Discovery Education. If an object is not accelerating, then the total force acting on it must be 0. Now, this doesn't mean it's standing still. It means it's moving at constant speed. And one possible constant speed is a constant speed of 0, not moving. Okay, so don't be limited. If it's not accelerating, it means it's not changing its motion. It does not mean it's standing still. Okay, I hope that's clear. Okay, hang in there.